This is a review of our factoring methods. As we go forward, you can see this is today we're going to be reviewing solving by factoring, specifically just the factoring part, and we'll look at four-term factoring. Tomorrow we'll cover rational root theorem, and throughout the week we've got new stuff you can see. Then we're going to review next week, and we should be getting ready for a test then. So today, like I said, it's kind of some review stuff. Here we've got our review sheet for all the methods of factoring. Now, what we're going to emphasize today, first off, is making sure we always do step 1A and 1B, GCF stuff. Then either we'll have two terms or three terms to start out with. Then we'll finally, at the end of the lesson, go to what happens if we have four-term polynomials. So here I've got my first problem set up. We're just supposed to factor this expression. So I just go to my list here. Number one is check for the greatest common factor. So part A is you check for a number. Now there's just a 1 in front of this, and since 1's only divisible by 1, that's the most I could divide anybody by. So that makes no sense to divide everyone by a 1. And while there's an x squared here, an x there, there's no x's in this third term, so I can't take out an x. So step 1A and 1B, we can't do anything. There's nothing to factor out. Then if I look at how many terms I have, I don't have 2 terms. I've got 3 terms, which makes me into this middle group for factoring. The first type, when you have 3 terms, is when the a value isn't shown. See how there's no a there, and there is in part B. If your a is just 1, like it is in this section, or like it is in your problem, you just factor it as x plus r, x plus s. So x plus r, x plus s, but r and s have some restrictions on them. R times x has to equal, r times s has to equal c, so that's 35. And r plus s has to equal b, which is negative 12. So that's, that's those two statements. Okay, so if I look at the things that multiply to give me 35, it could be 1 in 35, or it could be 5 times 7. Well, I want the 5 and the 7 because they add up to 12, which is the middle term. Now, the middle term is a negative 12, so if we make these both negative, now they add up to a negative 12, and they multiply still to a positive 35. So it's minus 5 and minus 7. We don't have to solve these or do anything with them. We are done right there. The problem is just factor it, and now it's factored. X minus 5 times x minus 7 is the factorization for x squared minus 12x plus 35. This next example, the next example here is very similar. Okay, it's got 3 terms in it. We start again with 1a, divide away any common numerical factors. Now this isn't quite true. This is for solving. We divide it away. When it's not an equation, see how this doesn't say equals 0 on it? When it's not an equation, you have to just GCF it or factor out things and keep track of them. In this case, everybody's divisible by 7, so I'm going to take a 7 out of everybody. And if I look at their x's, x cubed is the lowest exponent. So they all have at least an x cubed in them. And so I'm going to factor that thing out of them. So essentially, I'm dividing each of these by this 7x cubed that I'm pulling out. So 7 over 7 is 1, and x to the 5th over x cubed up there is x squared. 161 divided by 7 is 23, and I have an extra x on top. And 630 divided by 7 is 90, and the x to the thirds cancel. So that's step 1 and step 2. I took out the number and the variable. Then I go to step 2, which is, do I have 2 terms or 3 terms, or 4 once we get there. These are 3 terms, and 3 terms always factor, if they are factorable, the same way. 2 parentheses. The beautiful thing is when your a is 1, I mean, you know what these are. It's got to be x and x. And then you just got to figure out what gives you 90. And so you list all the factors until you find a pair that add up to 23 in the middle. 5 and 18. There we go. 5 times 18 is 90. And 5 plus 18 is 23. So when these two are added together, I get my middle term. And when they multiply, they give me the c value. So there's my factorization. Not solving these, I'm done. In our next example here, we've got three terms. Okay, so I'm going to be somewhere over here in that second pile of factoring methods. I'm going to check for a GCF. Now I've got a 2 and a 15. They're not both even, so not divisible by 2, so I can't take anything out. 18 is divisible by 2, but the 15 stops us. They don't all have an R in them. 18 doesn't have one, so I can't take out a GCF. So it's three terms. I've already done these, nothing to be done. Three terms, but now it's going to be this B one. Okay, because it has an A value, and the A value here is 2. And so here's what it says. It factors as AX plus R, AX plus S. So 2R and 2R, where R times S equals A times C. Let's see what our A times C is. 2, that's my A. C, that's my 18. So they're going to multiply to 36. So let's see what multiplies to 36 here. 1 and 36, 2 and 18, 3 and 12. There's the pair I want, because those add up to 15 in the middle. So one of these is plus 3, and one of these is plus 12. Now careful, this is not my answer yet. To get my final answer, I take my two factors and rewrite them, simplifying. And so here's the one I want. Everybody in the second binomial here was divisible by 2, so you have to do that. See, now that's correct factorization. You'd see 2r times r, when you distribute, is 2r squared. 3 times 6, when you distribute, is the 18. And this product, 12r, and this product, 3r, add up to the 15 in the middle. And so we've got it factored there in green. This next problem is kind of a peculiar problem. It does have three terms, but it's x to the fourth. Well, this is actually called being in quadratic form. In fact, you could do this as a quadratic equation. You'd have to do something like let b equal k squared, and therefore b squared is k to the fourth. And if you do that substitutions, now you can see where there's a k to the fourth, it's b squared. Where there's a k squared, it's just b. You can see that this thing can be written as a quadratic equation. You could actually factor it this way, using this quadratic form. However, when you get done, you have to do some more work, because b is actually equal to k squared, so now it becomes k squared minus 2 and k squared plus 5. And so that would be your factorization. Now, you usually don't go to all this work. What we want to do is just recognize that, hey, it's got three terms. Let's get rid of a bunch of that junk. It's got three terms. This is to the fourth. This is half as much, k squared. And when it's like that, you know it's got to be a k squared in each of these spots. And whatever goes here and here, they still have to multiply to c. So 10 in this case, so that's 2 times 5, positive and negative. Now they add up to 3 in the middle, and that's your factorization. You don't have to go to all that work of substitution. Just recognize, hey, it's going to be a k squared and a k squared. That's all of our three-term polynomials. Now we're going to look at some two-term polynomials. Now remember, all of these, when they have two terms, we still want to do the step 1, check for any GCFs that we can take out. And then step 2, these are all two terms. So they're either a difference of squares, they're a difference of cubes, or they are a sum of cubes. It's just going to be one of those three after we've checked the GCF. So here we go. 4 and 121 not divisible by anything. Second term doesn't have any z's in it, so we can't take a z out. So this is a difference of squares. Now, here's how I would factor these. Well, let me show you first the real method, and then I'll show you how I do them. So the first thing you want to do is rewrite it as something squared minus something squared. And see, now it's written as a difference of 2 squareds. A is a 2x, and B is a 11. And the formula that is given to us for a squared minus b squared is just a minus b, a plus b. And so it's just 2x minus 11, 2x plus 11. So that's how we do it. But I think it's much more efficient to do it the following way. And it saves us, I think, some time. What you want to do is you go, aha, difference of 2 squares always factors to binomials. And you just got to go, oh, what gives me 2x or 4x squared? And they got to be the same number. And what gives me 121? They got to be the same number. And they just have opposite signs to get the other stuff to disappear. And if you get used to that pattern, you'll start to see there's a limit to how these problems can be. There we go. So I go, ooh, difference of squares. How do I know that? Well, 9 is 3 squared and 25 is 5 squared. And I now know it's 3x minus 5, 3x plus 5. Okay, so those are the difference of squares, done very, very easily. Here's another one, 81x squared minus, oh, let's not use 9, because then there's a GCF. Let's use 1. There we go. This is like a 9x that's squared. And so I go, okay, 9x times 9x, that gives me 81x squared, and 1 times 1 gives me 1. I'll make 1 negative, 1 positive. I'm done. All right, sum of cubes. Now, when you do the sum of cubes and difference of cubes, you do want to write them this way, as something cubed plus something cubed. In this case, to get a 125, you'd have to cube a 5, and then c cubed is c cubed. And to get a 27, you'd have to get a 3. You do not just drop the 27 down there, okay? 3 cubed is equivalent to 27, so we can rewrite it that way. And now the formula, you just have to look at your sheet, and the formula says if you have 2 things that are cubed and added together, it will factor as the sum of those 2 things, then the a squared minus the product plus the b squared. And so we've got a 5c that we're putting in, and we have a 3 that we are putting in. And so I go, okie dokie, that's 5c plus 3. And it says, take the a value, that's 5c, and you got to square it. Well, that's 5 times 5 and c times c. Then it says subtract and take a times b, so 5c times 3, which is 15c. And it says take the b and square it, so that's a 3, and we got to square it, so that's a 9. There we go, there's how it factors. And we're done. Our last one, we see that difference, we see that cube, we think difference of cubes. It's got to be a 2 that they've cubed, and a 5 times 5 times 5 is 125. There's my a cubed minus my b cubed. Factorization, a minus b. So 2z minus 5. Then a squared, so 2z times 2z. Plus a times b, 2z times 5. Plus b squared, 5 squared. And you're done. 5 squared is 25. There's the complete factorization. All right, now our very last type, 2 ones. Now this is an example of when we have to factor by what's called grouping, or sometimes referred to as regrouping. But we use this whenever we have 4 terms. So if you look right here, we've got 1, 2, 3, 4 terms. And the method is as follows. What you want to do is group the first 2 terms, then put a plus sign, then group the second 2 terms. So your first step looks like this. 2p cubed plus 5p squared. And let's make this a nice prominent color here. Super important to put this plus sign. And then we group the other two terms together, like so. So that's all you got to do in step 1 when you have these 4-term polynomials. Now in step 2, we're going to GCF each group. So here's our first group, and we're going to just look at and figure out what the GCF is. We've got a coefficient of 2 and 5, so no number divides into those evenly. The p's, we got p cubed and a p squared, so we can take out the lowest exponent one, the p squared. So we'll pull out that p squared, and left inside the parentheses would be a 2p plus 5. And our plus sign. And now we're going to GCF the 6p plus 15 here. So if we look at the number, 6 and 15 are both divisible by 3. We can't take a p out because they don't both have p's in them. So we'll just take the 3 out of the 6 and the 15. So we'll take that 3 out, leaving us with a 2p plus 5. And this is the really important thing, that when we do that GCF on both of these groupings, notice how we get these like terms right here. They're actually not like terms, they're like factors. This is the first term, and it's p squared times 2p plus 5. So 2p plus 5 is a factor. This is the second term. It's 3 times 2p plus 5. So 2p plus 5 is a factor. And so it is a common factor, this 2p plus 5 is, of both of these terms. And we just have to factor that thing out. So I grab that 2p plus 5 and I pull it out of the first term. And I'd be left with a p squared. And then when I pull that 2p plus 5 out of this second term, I'm left with a plus 3. And it is now factored. It is now written as a product or a multiplication of a binomial times another binomial. If you want to check this really quick, you'll see if I distribute, I apologize for my dog, but as I distribute this, you can see that we get the original polynomial that we started with, which is the entire point, to come up with the multiplication that gives you the original thing. So we got 2p cubed. We'll put the 5p squared second. Then this p plus 5, plus 15. This 5 times 3. And you can see, yeah, it does multiply to give us the original. So this is the correct factorization right here. So there's our steps, okay? Group the first pair, group the second pair, put a plus sign between those two groups, and then just GCF them both a couple of times. So here's our last example. We can see we've got 1, 2, 3, 4 terms. And so we'll attack it just like we said before. We're going to group the first two terms. So we'll have a z cubed plus 5z squared. We'll put a plus sign. Then we'll group the second pair of terms, negative 4z minus 20. Again, notice how we put the plus sign in there. If there's a negative, we capture that in our parentheses. Very important to do that. Now we just have to GCF these. So I look here and I can't take out any numbers. I got a coefficient of 1 right there. But I can take out a z squared. So we'll factor that z squared out. And we will be left with a z plus 5. So this is kind of a z plus 5. We're hoping this factors to give us a z plus 5 as well. And as we look at these two terms, I had a quick crash there. I'm not quite sure where I was at, but we'll continue on. When I GCF these two, I can see I could take out a 4, but I'm going to take out a negative 4, because when I take out the negative 4, I end up with a z plus 5, exactly what I need so that I have these common factors. And that's the common factor I yank out now. So I pull out this z plus 5, and I'm left with, in blue, the z squared minus 4. Now that's exactly where we stopped in the last one. This one we could stop here, but we should really keep going, because notice this binomial is still z squared, and this 4 is also a 2 squared. This is a difference of 2 squareds. And so we've seen how that factored in a previous problem. We'll just factor z minus 2 and z plus 2. And that's your factorization. This goes with assignment, EDA assignment number 19, I believe it is.